In this section, we want to solve tangent line problem. And in order to find a tangent line, we need the slope. So let f of x be a function defined on an open interval containing a. The tangent line to f of x at a is a line passing through the point a, f of a, and have the slope m of the tangent line equal is a limit as x approach a, f of x minus f of a, all over x minus a. So once we have the slope and the point, we can write the tangent line to be y subtract f of a equal the slope of the tangent line times x subtract a. So the first thing we need to find is the slope. Now alternatively, you can define the slope of the tangent line to be limit as h goes to 0. F of a plus h minus f of a all over h. And it depends on which definition you work more convenient for you to work with. You can choose either definition to find the slope. And in our textbook, we have example using both of them. Now we'll take a look at this example. Find a tangent line of the function f of x equals x squared at x equals 3. We can choose either of the formula, but the first one is going to be more convenient. So we have to find the slope of the tangent line. And according to the definition, it's the limit as x approach a. And in this case, our a, and you need to identify a. A is 3. So instead of rewriting the a, you just replace a by 3. And the x, never change x to 3, okay? Because x is the variable. What we need to identify is the point a. So now you know a is 3, and you just keep all the x. So f of x minus f of 3 all over x minus 3. Then you'll be able to find this limit. So then you replace f of x by x squared, because that's the definition of f of x. So f of x is x squared. That is the function, okay? Think of f of x as the function. The function is x squared. And then you subtract f of 3. F of 3 is x squared. So what is 3 squared? 3 squared is 9. And then all over x minus 3. Or you keep it as 3 squared, because you know in order to find the limit, we need to factor, because direct substitution gives us a 0 in the denominator. So we're still finding the limit as x approaches 3. On the top, we can factor, and it's difference of square. So we have x minus 3, x plus 3. In the bottom, we have x minus 3. So we can see the cancellation. And when we cancel out a fraction, the remaining is the 1. So then the leftover is limit as x approaches 3, x plus 3. And we don't leave it this way. We're evaluating a limit, and we have the number. When we evaluate a limit with a number, you need to know the answer of a limit is a number. So we plug in x equals 3 at the very end to get that the slope is 6. We are still not done with the problem, because we only have the slope. So the tangent line will be using the point slope form. So y minus f of a. So what is f of a? A is 3. F of a is just f of 3. 3 squared is 9. Okay, so y minus 9 equal the slope m, which is 6 times x minus a is 3. So we can leave it like this, or we can change it to the slope-intercept form, but it's not necessary. Okay, if you leave it this way, it's very easy to see what is a point and what is a slope.